Now we will proceed to the special type of problems. Okay, so in the special type of problem, the first problem we are choosing, that is a set square. You can see for the construction of a set square they have given two angles here, 30 degree and 60 degree. Set square of 60 mm longer side is so kept such that the longer side is in HP. So we have to keep the longer side in the HP plane. So making an angle of 30 degree with VP, the set square itself inclined at 45 degree to HP. So we have to draw the set square. So the main thing in this problem is we have to construct a set square. That's it. Other than that, it will be similar to your normal type of problem. Okay. So I'll be showing how to construct a set square here. So the problem is easy. Only thing here is we have to construct a set square. Okay. So how to construct, you can see that first we consider a longer side 60. 60 means 6 box. Okay, so longer side 60 I have drawn. Now you can see 30 degree, so this is the internal angle difference, 30 degree. So the external angle it will be 60. Okay, so from here can mark for 60. Okay, sorry, it's not, it's 30. We have to mark for this point, mark 30 degree. Okay, 30 degree. Okay, so here, so we have to mark at 60 degree. Okay, so here 30, so this is 30. Okay, and this is 60. So this angle, how much we got? This is 60. So this is what the 30 degree 60 degree set square. Okay, so in this you see it, so we have drawn with respect to the question given. So we will be showing the dimension. Okay, 60. So we have drawn a with respect to the longer side, and we will be giving the naming for it A, B, C. Okay, to project it to complete the front view. So it is A dash within bracket B dash C dash. Now angle of inclination to HPT is 45 degree. So that is A dash B dash we have taken. The angle how much it is? 45. So mark for 45 degree. Okay. Now we have to cut the arc from A dash to C dash. Okay, same procedure how we did the normal type, so it is same. Only thing here in this, we have to construct this set square. Okay, other than that everything remains same with respect to the normal type. This is A and this point is B and this point is C, so we will join it. Okay, so now we have to draw the third position, that is inclination to VP, it is 30 degree, marking a reference point. So mark for 30 degree, draw an angle line. Okay, so this is 30 degree. So after this we have to mark a reference point A. Okay, so from A to B we have to measure, we have to copy this diagram over here, that's it. So cut the arc. So this is the diagram, we are copying it. Okay, from now A to C, first arc, and then from B to C. So we get C here. Okay, now we have to join. Okay, so to complete the final position here, so here we get A dash. Similarly, we got B dash here, and C dash we are getting here. So this is C dash. So now we will join to complete the final B. So that's complete the problem. Today we are going to learn another special type of problem on the isosceles triangular plate. Okay, now we will proceed with the question. Isosceles triangular plate of negligible thickness has a base 25 mm long and altitude 35 mm. So they have mentioned these dimensions: base dimension 25, altitude 35. You know how to construct the isosceles. I will show you how to construct. Now, before construction, it is so placed on HP. You can see that it's telling that, so it will be placed on HP such that in the front view it is seen as an equilateral triangle of 25 mm side. So he's telling that it will be placed on HP, but in the front view we have to get an equilateral triangle of dimension 25. So with the side that is parallel to VP, with the side that is the side which will be parallel to the VP, okay, so that will be inclined at angle of 45 degree to VP. So you can see in this question they have mentioned only one angle of inclination, that is 45 degree to VP. So there is no angle of inclination to VP given. Instead of that, they are telling that with the side that is parallel to VP is inclined at 45 degree to HP. So second angle of inclination they have not mentioned. Instead of it, they have mentioned second view. Okay, the second view, it is an equilateral of dimension 25, and it is an front view. Okay, so in the front view, so we have to get an equilateral triangle. So before going to the problem, first we have to identify, is it resting on the HP plane or on the VP plane. So for that I'll be doing a trial. Okay, in trial 1, what we do, say this is our XY VP HP. Say we have constructed with the if we placed on the HP plane, what happens? Say this is our isosceles. Consider this is altitude. Okay, top view. So this is front view. Okay, now by inclining this, we'll get a here equilateral triangle. We will construct it. Then by projecting here, we get the angle. But herein you can see this equilateral triangle we are getting in the top view. Okay, so this is top view. This is wrong because we have to get an front view. Okay, we have to get the front view. So this trial is wrong. So similarly, we'll go for the trial 2. So we will try for the trial 2. You can see in this we will construct here. Okay, such that one of the corner touching the it is in the vertical plane, but it is one of the corner, it is resting on the XY line. If it is resting on the XY line, means it is touching on the HP also. Okay, it is placed like this. You can see this. Say consider this is horizontal plane, this is vertical plane, and we have placed we have placed like this, okay, like this we have placed like this equilateral triangle, say. So the equilateral triangle, it is in the vertical plane, but one of the edges, okay, corner, it is touching the base edge, it is touching on the xy line. On the xy line means it is touching the xy line, okay. So that's how it is. Say this is the front view, then projecting downward we get the top view. Now in this position they have not mentioned the second angle of inclination, so we have to construct a triangle here, okay. Equilateral triangle of dimension 25, okay. Dimension 25 we have to construct. Then we have to, by proceeding like this, by taking this length, we can find out this angle of inclination, okay. So this trial to it is correct, because you can see this is equilateral triangle, so we are getting in the front view, okay. And you can see that, so both the conditions we have to match, so it is so placed on HP such that in the front view, so we are placing an isosceles triangle in such a way that it is touching the HP plane. So how it is touching the HP plane? By placing on the xy line, we are making this one of the end touching the HP. So when it is inclined, in the second position, it is seen as an equilateral triangle, okay. So when it is inclined like this, okay, when it will be inclined like this, we are seeing an, so we are seeing an equilateral triangle of dimension 25. How it is means, say like this. So say consider this is our isosceles triangle, we have placed like this, and in second position we are inclining, we don't know how much inclination, we are inclining an isosceles triangle here, but in the front we are getting an equilateral triangle, but we don't know how much angle, so that angle we are going to find out, okay. So I'm proceeding with the question, so all of you carefully follow it. So this condition is correct, so all of you carefully follow. So first I will draw an xy line. So drawing the xy line is compulsory, okay. VP, HP. So first I'm constructing isosceles triangle. First I consider base edge, that is 25, okay. So after constructing base edge 25 exactly, I will show the dimensions initially, okay. So exactly at the middle of this we have to consider a center point. So it is exact 25 means it is 12.5, somewhere here we get, okay, 12.5. To this 12.5 we have to mark altitude, okay, altitude of 35, straight line, horizontal line of dimension 35, exactly 35 you have to draw a straight line, okay. Then after drawing 35 you join this, okay. So this is what your isosceles triangle. So we are giving the naming A dash, B dash and C dash, okay. So when we draw the top view of it, so we'll get it on this xy line only, okay. So it is A and B will be in bracket and C. So this is what the top view, but in this second position, angle of inclination to VP they have not mentioned. Instead of that they are telling we get an equilateral triangle of dimension 25. So I'll be drawing an equilateral triangle here by taking 25 dimension, okay. So this problem is a little bit different, that's why we call it as an equilateral triangle, special type of problem, okay. So we know how to construct equilateral triangle, dimension 25. So in this problem they will be not mentioning one angle, instead of that they will be telling one view, okay. So in this we are getting a front view, okay, front view. So in the front view we are getting an equilateral triangle, okay. So it is A dash, this is B dash and this is C dash. So this is a equilateral triangle, but we need to find out how much inclination we get it here, how much tilt we have to do this isosceles triangle such that we get a equilateral triangle here, okay. For that I'll just drawing an projection line here. Here at this point I will take a reference point here, A of B, then measuring this line A to C, we are measuring this length A to C, measuring this length A to C. I am going to cut the arc. Okay, so yeah, so now we can find out how much angle of inclination it is. So herein I'm getting around 50 degree. You have to get 52. Okay, 52. So I'm getting 50 degree. Okay, so now we have done the second position. You can see in this problem how it is proceeded: 1, 2, 3 and 4. First we have drawn this, second, third and fourth. Now fifth. You can see in this question, with the side that is parallel to VP is inclined at 45 degree. So this is what A dash, B dash and this is what parallel to the VP. Now we have to incline this end. Okay, we have to incline this end by an angle of 45 degree. So how we do that? So here we are marking a point of B dash. Okay, so here at this point I will be taking an angle of 45 degree. Okay, drawing a line. Now measuring this end, because this is what the end A dash B dash end is parallel to VP. So I'm going to cut the arc. So this is A dash. Now similarly with the same length we have to construct a triangle, same dimension 25. Okay, it is already measured 25. Okay, now we join this. Okay, you can show the angle here, it is 45 degree. So now we can write the notations. So here I am getting A and this point is B and this point is C. So join it. Okay, so these are completed. This fifth, sixth. Actually this problem it is proceed like this. Okay, like this in the arrow direction. Say first we constructed this, second position, third, fourth, fifth, sixth. In this problem they have mentioned only one angle, that is angle of inclination to HP. They have not mentioned the angle of inclination to VP. Instead of that they have mentioned one V, that is equilateral triangle of dimension 25. So this is all like this. Okay.